Dear colleagues, dear friends, it is my pleasure to welcome you at our winter school, and also it is my pleasure to meet Axel Schulte. He is the head of the Department of Blockchain and Supply Chain Management and a senior lecturer at the Department of Operations Management at Graduate School of Management, St. Petersburg University. Axel's research interests include supply chain management and financing, strategic procurement management, digital technologies in supply chain management. Dear Axel, the floor is yours. You may start, please.
Yes, thank you, Andre, and thank you for the introduction. And I will also start with the introduction also of my colleagues. Let me check. I brought two colleagues to the floor today. One I see is Eugen Burov. You see him, and let me just check if Timochin is there already. Eugen, do you see him? No, not yet. Well, he will join us in a bit. Okay, and my first question would be, the participants are all, well, what do we have? Students and professors, as I see, right? A mix. Is there also corporates in the room?
So I think that mostly the audience is the professors of the universities, and maybe if there are practitioners or students, could you please say?
Okay. Okay, maybe some more will join in the course. So, yes, there's my other colleague Timochin. Is there as well. Yes. So we are three today. I brought two of my colleagues working together with me in some of the fields Andre just mentioned, and we prepared a presentation, quite a comprehensive presentation that we're happy to share with you afterwards. So we probably won't be able to go through everything, but maybe I share this with you right from the beginning. Just so that you see what is on the agenda, what we planned for this meeting today, okay? But before that, let me just give the chance to introduce Eugen and also Timochin. Maybe you just briefly, Eugen, just 1 or 2 minutes, say something about yourself.
Hello, everybody. My name is Eugen Burov. I'm working with Axel Schulte together at the Fraunhofer Institute, where my main focus is in the linkage between the physical and financial supply chain through emerged technologies, and also the implementation of blockchain IoT in the industry here in Germany overall. And today I will take part of the blockchain and IoT applications for supply chain management and finance area.
Give you a little insight in in the second part, and the third part will be done by Timochin. Just a few words from your side.
Hello, my name is Timochin Korkmaz. I studied computer science at the university in Dortmund, and I also work in the department from Axel Schulte. And my task in our team is to build a bridge between our technical colleagues, which have their focus on implementing the technological aspects of our work, and on the other side to make a bridge to the industry and link these two parts together. And I will try to give you a technical insight on the aspect we are working on.
Yes, thank you. And when I will start now with the presentation, I will also introduce a little bit the institute, and there you will understand a little bit better the background, where we're coming from, what we focus on in our research. We have also one surprise here in the team. Eugen is also able to understand and speak Russian, so you can test him if you want to. Eugen, maybe just say one sentence in Russian so that everybody believes me.
Здравствуйте все, очень приятно вас увидеть и посмотрим, как наш тамин сегодня будет.
Really nice. Thank you.
And the reason for that is what, Eugen? Or you just said that?
No, I just said that it's really nice to meet everyone, and I'm looking forward for our meeting today.
Yeah.
And yeah, maybe I can say 1 or 2 sentences to me also, that I was born in Kazakhstan and moved to Germany when I was 3 years old. So my Russian isn't the best. I can understand everything and communicate a little bit, but I think for the benefit of us all, I will hold the presentation in English.
Yeah, that's right. Yeah, very good. Thank you, Eugen. But I thought it's nice, not only because that is not the reason why I brought Eugen, but it's basically also a topic fit and personal fit. So, and I remember when I hired Eugen, I was very, I paid attention to his CV and saw that he was speaking Russian. And since I'm very well connected and attached to Russia and to St. Petersburg and to all of you over there, thought it would be an additional nice thing to have someone on the team who also speaks Russian. Good. Okay. So what I will do, if there are any questions, yeah, there's a chat room. The first question is already coming in. Will there be a recording? To be honest, from my point of view, I'm okay with it. The thing is, we are more used to working with Teams, Microsoft Teams. So if not sure about the features, what feature we would need to do this. Also, so if anybody who organized that, Alina, are you there, or Andre? Maybe you can
already recording.
Feel free to record.
Yeah. So Marina, she is available as a winter school at this session, Zimняя школа, so in Russian. So she is responsible for technical support of this event, and also she has started the recording already.
Okay. Okay. Good to know. So in the meantime, I checked here the features, so I can just share my screen, right? And when I pass on to you, Eugen, then I unshare and then you share, right?
Mm-hmm. Yeah.
Okay. So let me just share. I downloaded the presentation. I hope I have the. That's the thing. So I need to find the right present. I think I just share my screen, right? It's probably the easiest thing to do. Okay, so can you see everything, everybody?
Yep. Emerging technologies in supply chain management.
Perfect. Okay, then let me just put this in presentation mode. I hope you see this as well.
Everything is good.
Okay, great. Good to know. The topic we selected, and I hope that finds your interest, is, and I shared that in advance last week, emerging technologies, and with a special connection to supply chain management. And you will see why it is supply chain management. It's basically because this is, as you all know, everybody who knows me over there, that is the area of research, education, and also the practical or applied research part that we are dealing with and are focusing on, and where we consider ourselves also experts. I will also say something about Fraunhofer, as I said. So we are in the middle already of the first part, introduction and welcome. And as last part of that, I will show you now a few slides about our background, so you understand better from where we're coming from and what we focus on. Then the second part I will also do is digital transformation, something everybody, never mind where we are currently, has to deal with. In Russia, it is a big topic as well. And I will come also to one of our top research topics, which is blockchain. So any any computer scientist or mathematician, whatever in the room. We also have developers, software developers in our team, and so we are pretty close to that area as well. Industry 4.0 is something that we're dealing with. I think it's a word creation from Germany, basically, but it's basically all the developments about those emerging technologies and the impact on industry it has. And one of those impacts is naturally the development of IoT, the Internet of Things. So in the third part then, blockchain and IoT applications, and also relation to supply chain management and finance will be done by Eugen. And then technology deep dive is done by Timocin, who will go a little bit deeper into what is behind blockchain and DLT. So the technological fundamentals and also some of the relation to what it means for when we want to implement this and set this up. We basically do that in many of our projects. You will see that. And so, yeah, let me just finish up, or let's maybe our introduction complete. Fraunhofer is a one of the big German research institutions. You see some of the figures here. It's basically the 72 institutes across Germany. We have 74 by now, so we're still growing. Actually, the research volume has exceeded now 2.5 billion. So these figures are actually from 2018. And also the number of employees. In Fraunhofer IML in Dortmund, we see some figures there. We focus on supply chain management and logistics supply chain management. You see that also in the background of Timocin. So we say we make 100% logistics. We consider ourselves the biggest logistics institute, research institute in the world. At least we didn't find any institute that is bigger than ours. And so that's where we're coming from. And we have a strong connection between logistics, supply chain management, and those technologies. Okay, so this is our focus. Yeah, this is our team. By the way, Konstantin, the head of school, Konstantin Kotov, he knows also very well Michael. Michael is a colleague of mine. And the other two guys you see there are also professors and institute heads in Dortmund. So we share some of those research things over these three topics, management, technology, and mobility. Everything again is for us is logistics. Yeah, we not only work at desks and computers. We actually also working with physical objects, which is when it comes to supply chain and logistics is obvious, right? I mean, but depending on how you define it, supply chain management can actually be everything, right? Manufacturing belongs to that, warehousing, the transportation part, all the IT and the infrastructures in between. So it's quite a broad and very complex field. And here you see some of those applications. All these pictures are they're not coming from somewhere from the internet, Google search or something. It's from our institute. So you see those moving objects. You see labs working there. Man-machine interfaces. So we also are developing our own, not only the software, but also the chips that we need. And naturally those vehicles you see there, they are also logistical objects. So just to give you an impression of what some of our colleagues do. We also work on computers. In my department, I'm a department head, as Andre in the beginning said. We focus on 4 areas, which are also reflected partially in my classes at GSOM, my lectures that I give. I have 2 courses. One is about financial supply chain management. You see that on the right side here, finance and financial supply chain management, connecting the physical and the financial flows of the global supply chains. So one of my lectures at GSOM is about that, one of my courses in spring. And the other one is about operations management and logistics. Okay, and so you see that here on the right bottom part and on the left upper part. So this is the other 2 areas. And on the left, bottom left, you see blockchain and smart contracts, and that's what we will go into deeper with you today and show you some of the things we do there, as mentioned before. Okay, so we see blockchain as one of those really emerging topics, and I know that in Russia it's also big topics. About a year and a half ago, I was in Russia with a minister on a delegate trip with the Ministry of Finance, Ministry of Economics, and we were at a conference where I gave a speech about blockchain and IoT. And so I know, and there were people from ITMO University in St. Petersburg. You're probably well aware of that university as well. So I know that there's lots of research and lots of development also taking place in Russia, and a lot of smart developers are coming from Russia. So I know that probably some of you, the people here in the room, also are familiar to that. Maybe, unfortunately, we don't have the time to start a discussion too much or to learn in detail what you are working on. But maybe we can do this in a follow-up. And Andrea, I'm happy to have a follow-up maybe early next year if there's a need for that. Okay. Okay, so here you see, as I said, stepping a little bit deeper into blockchain. All these are, you see me here presenting at a conference, one of our latest developments. It's called the Node Runner. It's basically an IoT object moving autonomously on the shop floor, and it's completely moving autonomous in swarms. So they detect other moving objects. We see a video later so you can understand it better. What we do is we connect blockchain and smart contract solutions to that in order to manage and operate those things, and for example, to initiate transactions, payments, pay-per-use models, etc. So blockchain is a very nice feature, nice technology that can be used for the connection of blockchain of IoT in that area. Here you see some other colleagues on the right side. We developed a gateway. We are also developing IoT and blockchain devices where we connect physical sensors, physical objects in the supply chain or on the shop floor, for example, connected to sensors or having sensors, being able to identify and send data, and use that data in order to put it on the blockchain and operate through smart contracts with that. On the lower part, you see a demonstrator we built. So we thought in the early beginning, that was 3 or 4 years ago, we actually started with this racetrack in order to explain what blockchain and smart contracts in supply chain management can do. And we actually have a real multi-chain based blockchain solution that we developed working on our own service, where we could actually with a front end and back end infrastructure. So pretty nice to show what blockchain means in the supply chain area. Prototyping, that was a workshop. So some of those things I will have to go through faster because if not, I will also have to look on the watch, because I don't know if you have any. We could stay in a little longer today, so but I don't know about your next meetings and times. So here a little overview. You can refer to that also later. I'm happy to share this material, as I said before. Okay. Some of the companies we work with, you see in the bottom. There's one more important comment I have to make is Fraunhofer does applied research. It's sort of a little bit different from fundamental research. So we have to also finance ourselves, our operations partially. We're partially state financed. We have a BICE funding from the government, but 70% of our budget has to come from projects that we acquire from industry partners or also from public partners on domestic level, on European Union level. So there's lots of, like in Russia, there's lots of funding, public funding for research. And I know that that's the way partially how you work as well. Yeah, so this is us. And now I would step into the second part, looking at the watch. I think we work, and we have time until 3 p.m. our time, which is, how is the time difference now? Is it 1 hour or 2 hours? Should be 2, right?
90 minutes for all.
90 minutes. Okay, now but in between. Very good. Is that the new time that was set and will stay constantly that way in Russia now? No. 90 minutes. What time difference do we have?
So it's 4 approximately 4 p.m. now.
Okay, so you're 2 hours ahead. Okay, good. So just give me a signal later on if you have more, if you want to spend more time with us. We could stay in a little bit longer if you need us. Okay, but so let me step into the second part. If there are any questions, to be honest, I didn't check the chat. Eugen and Timo, if there are any questions that you want to answer in the meantime, or if you want to interrupt me because there's a critical question, just let me know, okay? Okay, digital transformation. Yeah, I don't tell you anything, as again, I don't know your exact background now that you have, but these are some of those trending technologies. And actually, they are not future technologies anymore. They are present. They're also part of our present now. We are dealing with those things, and you as well, on a more and more daily basis. But there still needs to be done a lot of research and a lot of development. So we have distributed ledger technology as overarching technology and expression also for blockchain. We will come to that. Very important for decentral network, autonomous, decentral transaction, etc. Big data, yeah, more and more data, as we all know, available. The problem is big data itself is not a value if you can't make sense out of that. So artificial intelligence or machine learning definitely brings those things together. The Internet of Things, IoT, actually everything more and more is connected. I talked about the sensors, very important in order to connect physical objects in production, supply chain, shop floor, whatever, to the data world. And so this is happening more and more. And a reason why this is happening and being more available also is that we have better infrastructures, right? We have much more capable systems, much more capable computers, storage, capacities, etc. So this allows us the basic infrastructure. Just one word that you're also working on in Russia, I know that, is 5G. We in Germany as well, everybody is dealing with that. So increasing capacity on this infrastructure side allows us to do more of those things, the other technologies that you see there, right? And we are all aware of that. So it's part of that. 3D printing is also development, material science advancing a lot. We have our own 3D printing labs at our institute because they are very relevant and becoming more and more relevant for logistics, for decentral operations, decentral maintenance, for example. I learned that we have a company in Germany that is developing not only vaccine for COVID now, but also actually the how do you say the cannula? How do you say that in English? For the injection, you need small containers where the liquid is in. You need the needle, right? And they are developing a solution that is actually coming completely, including the liquid, the vaccine, out of the 3D printer, which would be revolutionary, because that way, in developing countries, for example, you can actually print this decentrally wherever it's needed. And that's so neat about logistics and the new technologies, right? So my statement here always is the true value comes out of combining all of those technologies. That's probably not new for you, but it's very important, and we are trying to help and to progress, to contribute to that. European Union statement here from the last year, 1.5 ago, president. You see that also on the agenda of politics on a global level. Artificial intelligence, blockchain, they're even part of the agendas of governments in Europe, and I know that this is the case across the world, and you know that as well. So as I said, we connect blockchain and IoT here. All of those things you see here is actually also developed in our institute. You maybe have heard of Telecom, the big German telecom company. We developed together with Telecom this tracker that can be inserted into pallets, the Euro pallets. So transport equipment where you can store small containers or whatever for transportation. And today these things are still, these objects, they are all, they're not smart, right? They're dumb, and these sensors can make them smart, and that's basically, and when you have them, and then when these, for example, these sensors are multi-sensors, they sense the temperature, they sense movements, they can sense heights, incline, they can sense shocks, humidity. So they're pretty smart, those sensors. So you can make any object very smart. And the thing is now, what do we do with the data? And there, blockchain is also in order to autonomize and optimize processes in supply chain networks, for example. It can be very big benefit to combine IoT and blockchain. So that's another good example. We developed for BMW these moving objects that you saw there. They're actually prototypes, but they are now being licensed based on license being produced by another company. We're not allowed to produce beyond prototypes. So we actually, at one point, we either make an own startup and put our own company, fund our own company and do that, or other companies will take over based on the license. That happened here with this device. So basically, BMW at some plants, this is already being used. We also have drones, actually also some in warehousing and logistics. So we try to, again, connect blockchain technology to these things that we do. The big potential of blockchain is that basically we can connect, as you know, there's lots of potential benefits of blockchain. Timothy and Eugen will also focus a little bit on more on that, why and where it's coming from. But we can basically connect all these levels, right? The different levels of starting from shop floor, where we can connect machines, IoT devices, whole production systems, supply chains, on company level, or even on complete value-added networks. So these different levels, we are not only connect financial and physical flows, we also connect the different levels of production, manufacturing, and supply chain management. And we are still on a global level, still in the beginning, right? This technology is still being explored. We are convinced that there will be very few business in the future and very few operations in the future where it's not earlier or later a blockchain will be involved. And so it's sort of like, as some refer to, the revolution that came with the internet. The thing is, not everybody, maybe some of you who are in mathematics and computer science are interested in how it works. At the end of the day, nobody who applies it, or not many people want to know how it works. They just want to know that it works and that business and applications and processes become better, smarter, leaner, and more efficient, or even provide new business opportunities. And that's what's important. That's what is important. So the goal is actually to advance this and to bring this into the real world, where it will provide us benefits, but we not necessarily need to see it in the future. Naturally, we are all engineers, so we like to know how it works, and we like to optimize. This is a picture we actually developed. We published a lot since a couple of years. It's sort of a little bit of vision of how we see a future supply chain network based on blockchain and smart contracts. And you see in the middle here a smart contract platform. And see on our levels, different partners along the supply chain. On the bottom level, the IoT devices can be a truck, can be any type of good that is connected through sensors again. And then you have the services that are also connected, banking services, insurance, or public services that can also be connected to this platform. And everything at the end of the day will be merging and bringing together physical and financial flows. So this is sort of a vision we have, and we're working towards with different use cases. One more thing, we also in this year in May, we started our European Blockchain Institute in Dortmund, and my department is heading that initiative. We have funding over 3 years from the North Rhine-Westphalian government. What we do is research, application, and networking in order to progress this technology, and in order to work on different use cases here, I just to speed up a little bit, some of those products we are developing there. So we will be very visible, and I'm happy to share links and share information. We already published a white paper on blockchain, on a specific blockchain technology, on multi-light node concept, which is very relevant also for IoT and blockchain again. So our goal and our target is to develop open source components. So we are developing software solutions, smart contract solution. Everything open source will be available to the public. Smart contract library, e-wallet is one of our projects. Blockchain devices, I will show you one, will be my last slide. We already have a blockchain device that we developed. We have, for example, we have very interesting processes, use cases already that we integrate. One is customs, and the other one is dangerous goods. And these two processes, for example, I can imagine are also very interesting for Russia. And I remember, Andre, we were working in this collaboration between Deutsche Bahn and Russian Railways, RGD, on the paperless trains between two customs unions, and so with different challenges, and we know that they're very aware that customs in international transport and logistics is customs procedures is very complex, and if we can digitize this process and facilitate that process, there will be a big benefit. So we are working on that. Also dangerous goods. And yeah, business model. So let me show you my last, again, you will see a lot of those things here. If you want to, if you're interested, we can share links. You can connect to me now, since we know us based on today, you can always reach out to me. I'm also happy to bring this to GSOM and to St. Petersburg University in the future. If you reach out to me, no problem. Happy to share. Yeah, before passing on to my colleague, to Eugen, and so I already said how we do this concretely. This is just out of our production. Actually, this is the blockchain device, the IoT device, and it was actually developed for monitoring of temperature-sensitive goods, such as medicine or vaccines, which is currently a challenge for logistics companies with COVID-19. So how can we bring the product, the vaccine, the solution to where it is needed in very short time? And also, we know that this vaccine products are very temperature sensitive. So this is a device that can track the temperature inside a box. You see the box in the background. It's works like a label, right? It's an intelligent label that has also some interfaces for operators. They can retrieve information. They can read out information with their smartphones and initiate and trigger the next process. You can actually track the position. You can track the handling. You can track location. And this is a nice device. And this is directly connected to the blockchain. It's also open source. So Linux-based processor is included, and an open source software, open source blockchain solution, the Tendermint framework. So this is what we developed. It's a pilot, it's a prototype, but it's sort of nice, and we already have the first request from industry partners who want to develop that further together with us. Okay, so just one idea. There's some more information here about the customs dangerous goods process. As I said, I'm happy to share. And yeah, I hope this gives you a little bit overview of what we do exactly. And now Eugen will step a little bit deeper before Timothy then does a little bit technological deep dive.
Thank you very much, Axel, for your introduction and for your description of the digital transformation. In my part, I would like to show you a little bit more about the possibilities of the blockchain technology and IoT applications in the supply chain management and in the financing area. Before we start, I would like to tell you a little bit more about the benefits of the blockchain technology for the industry, so you have a better background and understanding for the projects I will show you afterwards. My colleague Timochin will tell you a little bit more about the benefits of the blockchain technology in general afterwards, but now we will go just fast through the points so you have a little background. And first of all, the blockchain technology, it creates trust. We have there an integrated consensus mechanism and an enhanced security, which creates better transparency between the participants of the blockchain. Also, the blockchain is administrated, so we have there a reading and writing permission, and we have there an improved traceability. And the blockchain technology itself, it is a basis for smart contracts. Smart contracts, if you don't know the meaning of it, it is a computer program that consists of if-else conditions. And with this, we have the possibility to automate process in the company or even in the whole supply chain. And this, of course, gives us an increased efficiency and reduces costs. And the blockchain technology is also an elegant software solution because it is very easy to implement new users into your network. It has a fast implementation and is very agile. And the next slide, yeah, perfect. And the next slide, I want to show you some projects we have in our institute, which shows perfect application of blockchain and IoT. Axel already told you something about the load runner I will show you, and also the blockchain gateway we created together with the Commerzbank in our enterprise lab. But first of all, the load runner. As you can see, also we have a slogan here, AI on 4 wheels, what it is exactly. First, why did we even invent such a new transportation system at our institute? Our institute director, Michael ten Hompel, you saw him in one of the slides of Axel before, our 3 institutes director. He said that the ideal logistics space is empty, which can use individual. And not only during actual times of COVID, we are facing high dynamics in the logistic, and that's something we need to face. That's why we need more flexibility, changeability, and also scalability in our logistic concepts and in warehouses to satisfy the needs we are having right now. And that's why I created the load runner. I need to try to start the video for you. Wait a moment. Ah, it works. Perfect. As you can see, the load runner itself it can move 360 degrees with a current speed of 10 meters per second. And it also has the possibility to drive 30 meters per second, which equals 110 kilometers per hour. And the packages can be easily picked up and even easier delivered, as you can see with the systems of a conveyor belt in the future. And the load runner themselves, they can communicate each other, like Axel said before. They have a swarm intelligence. You can imagine them like a swarm of bees. So if they're facing some difficult task or bigger task to move a larger object, they can communicate together, link themselves, and then transport or complete these bigger tasks by themselves or together in a group. And yeah, besides the high speed sorting you saw in the video, which is a ideal use case for these load runners, there are also other examples how these load runners can be used. Like I said, they have the sorting function in a warehouse, for example, And other fields could be the usage in the airport environment, for example, for the baggage drop, or if you have a factory that is producing goods for the production supply or even the production disposal. These load runner could handle the whole logistic on the shop floor level. On the next slide, yeah, there it is. We have a summary of the load runner. In summary, we can say that the load runner is a research project still, but yeah, it's a research project for autonomous swarms of vehicles that perform tasks based on the artificial intelligence and blockchain technology. And the blockchain itself has here the function for the documentation of for documentation of the negotiation results between the load runner themselves, for the internal data exchange, tracking the transactions, and also the smart payments for new business models, like, for example, pay-per-use method that can be achieved here with the blockchain technology. And I choose the load runner as a first example because I think it really shows how emerged technologies can work together and create such an innovative product. Because here in the load runner, we have robotics in them, we have IoT, we have IE, and also blockchain, and they can combine. And the load runner combines all these technologies on the shop floor level, which is really innovative. The second use case or project I brought with me is the blockchain gateway. Axel also teasered in his part. And before I come to the use case, I would like to talk a little bit more about the motivation and the potential behind the transformation of existing sensors into smart sensors. And we are now in a time area of the digitalization, but by far not all devices we have are smart or IoT ready, or even machines are not already on this level. And with the help of the blockchain, we have here now a technology that helps us to transform these industrial sensors, which are now stupid, you could say, into a blockchain-ready oracle for relevant data. And in the area of the automated transaction banking, this is a technological breakthrough, because there isn't any similar solution for automated transactions that can be triggered by the machines or by the sensors themselves. So we can also set a technological standard by this innovation. And what are the potentials behind all of this? Why are we investing so much time in it? Is because we now have the possibility to obtain data directly from the physical supply chain. So we can create a digital image directly from the physical supply chain without any other participants between. And so there won't be any faults or misinformation we could send through our blockchain and trigger there some services. And this direct connection to the physical supply chain gives us the possibility to use smart contracts and have automated processes through the whole supply chain. And the biggest potential we can reach with such a transformation of the sensors is the data collection or the data gathering we can achieve. This sensor, the blockchain gateway itself, we developed in cooperation with the Commerzbank. So we looked here more in the aspects of the financial institute, and these data collection we can achieve with the new sensors or the added sensors is for the bank, for example, they have much better risk quantification. They have a better understanding of their customers' business. So if they rate their customer depending on their know your customer policy, they have a much better overview. And also, if you think a step further, going from know your customer into going know your object. So the bank is knowing which machine or sensor is registered to which customer, and is the machine also really producing the amount or in the way it was purchased. And that's a lot of things on or information the bank benefits from itself. And also it gives us a base for information brokerage and trade business, which let us say that information becomes tradable. And so we have here added value we can gather from data which is already generated, but now we can make money out of it, or have an added value, or can recycle them. And how is the blockchain gateway used, or where is it used right now? We have an cooperation with or collaboration with other enterprise labs at our Fraunhofer Institute, where we are looking at the CPAT management for our silicon economy. It's a project for the vision of a silicon economy compared to the Silicon Valley we have in America. And here in this use case we created, we have 4 parties. First of all, it's the Commerzbank, which is responsible for the payment, for the financing, and overall for the cash flow above the supply chain. On the other side, we have the company Würth, which is responsible for the CPATs management and the supplier management. We have Deutsche Bahn Schenker. They are transporting the physical goods from Würth to the customer, and also do repackaging process of the goods into containers that the customer is using. And last but not least, we have the company SIG, which is a sensor technology provider, and they developed a packing station or repacking station for this case with, you can think about it, it's like a normal working station, but in this working station there is an integrated barcode scanner and also a scale. And with this, with these information about the weight of the goods and the scanning the container or the package, they can identify if it's really the right amount of parts, and if it's really the right product Deutsche Bahn is delivering from Würth to the customer. And this is also the place where the blockchain gateway comes in scene, because we have now the opportunity here to connect the blockchain gateway to this working station or to this repackaging station, and make it IoT ready or blockchain ready. And write these information we gather there from the weight and the scan process into the blockchain, so we can document the process and also have their automated service solution for the customer. For example, if we scan the right goods and Würth confirms that it's the right order, there could be an automatic payment that comes after the scan process, or after Deutsche Bahn Schenker confirms that the transportation of the goods is finished or it was delivered to the customer. And yeah, this gives us a lot of added value. We can use the data and create an overall product for the customer and overall for the CPAT management. Another use case we developed in our Commerzbank corporation is the use case of the smart waste management. Here we have a collaboration with Renos Logistics and Deutsche Telekom. In this use case, we look at automated and individualized waste disposal based on narrowband IoT sensors. So we also equip normal paper bins or a paper container and make them smart with sensors. So that, for example, on the one side, the waste disposal company have an optimized route planning. And you can see here in the graphic on the lower side, there is the developed sensor. The sensor is placed into the paper bins and is there measuring the fill level of the container. And this information will be sent frequently into the cloud, and the cloud has also a function as a light node. So these information from the sensor will be written on the blockchain continuously, and if the fill level of the container has reached a certain level, this will also be written on the blockchain, but there will also be a notification for the waste disposal company to empty the container. And they can plan their routes afterwards to optimize their routes for emptying the container. And on the other side, the Commerzbank has a possibility after the container was emptied that the sensor resets, and we now have the possibility to have an IoT triggered payment after the process was finished. So we have an autonomous payment in here. What are the benefits of this for all the parties here? First of all, we have the Renos Logistics, who now have a better disposition, and also new business models like, for example, pay-per-use they can use on their customer. The customer, on the other side, he has a guaranteed capacity of his paper bins, and he's also only paying for services he is using. And overall, he gains a lot of transparency and security. And on the other side, Commerzbank, they are now developed or now established an IoT triggered payment and automatic accounting. And now if you think about it, okay, why are we just looking at waste disposal at this whole use case? This is the first example how these IoT triggered payments could be function. If you think a step further beyond this whole thing is that we are creating here a technological breakthrough for IoT triggered payments. There will be around 2025, there will be around 45 billion IoT devices worldwide. And if every device could trigger an automated payment or even has the function to pay for themselves or for the services they are doing at the companies, that will be such a big benefit. And yeah, this is why the project is really coming at our institute, and we are really eager to develop it even further beyond. I see, Axel, you're unmuted. Do you have an addition to say?
No. I was just looking at the time and was going to mention now for the next slide that we need to, because we have 1-2 use cases more speed.
Mm-hmm. Okay, I will shorten the next
time.
slides. Yeah, no problem.
I think.
Shorten them. Are there any questions in the chat? I can't see the chat.
No, I don't see any.
No? Okay.
I think that we may ask questions in the end of the presentation, because to give time to Timothy also.
Yeah.
Okay, maybe you can skip some slides now and we will provide that. Just say maybe two this, and then we can pass on to Timo.
Okay, no problem. Here on this slide, we have some industry projects. Here in this example, it's a dynamic discounting platform where the buyer, in this example, it's the middle-sized company EOT, can improve their payment terms with their supplier. And the blockchain also has here the function as an auction platform and the documentation for these auctions. And yeah, and the benefit for both sides is the buyer has better payment terms in the end, and on the other side, the supplier can get an early payment, and also there aren't any loans from credit institutes necessary. On the next slide, there's the industry project with Peel, where the blockchain isn't used as it's usually. Here, the blockchain has a function as an adapter to the ERP systems. So we have a standardized data format for the data exchange, and it is used here as an intermediary and a secure and encrypted communication channel. And the last project or use case I brought with me is a track and trace in the supply chain. And here on the upper picture, you can see the whole supply chain. It is for baby wipes. And we have here the possibility with the blockchain that every step of the supply chain is documented in the blockchain and tracked. And if there are any problems or maybe side effects from the customer side, he can document this or report it. And the producer has a possibility to look where the batch of baby wipes is coming from, what ingredients or what supplies were used, and so they have a better audit and much better quality management in the whole process and in the whole supply chain. So, okay, up a
this
little
project,
bit.
the last one, just one comment, is we do with Singapore. So it's a global supply chain we're looking at.
Yeah, right.
Thanks a lot, Eugen.
So that was my part, and now the next one, Timochin, will tell you a little bit more about the technology deep dive.
Thanks, very good.
Thank you, Eugen. I hope you can understand me very well. Yeah, my IT infrastructure just started to have issues right before this meeting. So if there's anything you don't understand or something like that, or any complication, just feel free to comment on it, and I will reply to the points. We heard a lot of the properties of blockchain technology and how it can benefit in the industry, but we still didn't hear something about the functions of it. How do we get these claims like reliable and tamper-proof? And we discovered that there's already also not a very clear definition of the blockchain technology. So we did some research and found a very fitting definition of it. How you can see here, we say a blockchain is a decentralized, distributed, tamper-proof, cooperatively used data memory, and it enables secure data exchange between nodes of a peer-to-peer network. The reason why I just repeat the sentence, which is already on the slide, is we will have a look on the parts, on the parts of this definition, and show you how we reach this claim, or how they are technically built. And and that will be the way how we get the parts for this definition, so that we can fulfill the picture of the blockchain technology like in a puzzle. So the first part will be a look on the history of blockchain. So where did it came from? It was initially just a paper from Satoshi Nakamoto, in which tried to define a way to transfer values and coins in this paper without any intermediary. So that was the first step. And already in 2009, the same, what we must say, anonymous source published an initial implementation of its paper, and that's what we know today as Bitcoin. But the technology didn't stay at this point. It went on, and with the Ethereum blockchain, there was the introduction of smart contracts within the blockchain, and then it also got on, and we came to the blockchain 3.0, where we didn't just have the transfer of values and not only the smart contracts which could handle the trigger in the blockchain network, but also include some other technical aspects like decentralized applications and further going new inventions. Just to show you the roadmap, how it went on and how it's still going on. So like we said in our definition, this technological evolution needed some basics. One of it is IT infrastructure, which is needed by every blockchain.
Can I ask just one question, Timo?
Yes, please.
And to everybody here, or maybe Andre, we would go now. Do we have a lot of blockchain experts here that are for whom this is already, let's say, common knowledge, or shall we go through it?
I think that in Russian, so this blockchain infrastructure is not used widely, I would say. So, and I think that these ideas and even basic ideas would be interesting for participants of the meeting.
Okay. Yeah. Okay. Thanks. I just wanted to check because I don't know exactly the background, and so yes, depending on that, I would have gone quicker or not. But still, Timothy, if we would go through those next slides in 20 minutes with some time afterwards too.
I would try to hurry up, but this is also for me good information. I just didn't want to be boring on the other side if you already know this information.
Go ahead.
So, so I said the IT infrastructure which is needed for almost every kind of blockchain is a peer-to-peer network where different machines can communicate in this network. And there are some important properties which should be named. And one of them is that the individual machines are equal to each other, and usually they are called nodes. And in this, these nodes have they process the data which is handled by the final blockchain infrastructure, and usually they have a full copy of the blockchain, and then so they are called full nodes, just to make sure where the naming came from. So the next step is we usually hear something about distributed ledger technologies and when we talk about blockchains. So there we have a little quick excursion about distributed ledger technologies. One thing is they are also depending on peer-to-peer networks or on distributed networks, if you have want a more widely definition of it. And the important part is the claims about distributed ledger technologies. They are also, like I said, hosted on a distributed system. They have nodes. These nodes are keeping information, and this information are usually transactions. And these transactions are collected in a ledger. And each node has a full copy of the ledger and synchronizes each other. So these are the main points which define a distributed ledger technology. And for this moment, we just keep that in mind, which defines a distributed ledger technology, and hop on to the data structure of a blockchain. Like I said, this other that maybe not seems to have a clear road, but these are these are the parts of the like the parts of a puzzle. At the end, you will see how they all come together. For now, we have the distributed ledger technology and its definitions. Now we have the blockchain and its data structure, and there are some similarities. We also have here transactions, informations held as transactions. And in the blockchain data structure, these informations are put together in a block. And the first information in this block is the hash value of the previous block. So we have a reference in each block to its predecessor. And at the end of this information, we have a new hash about all the informations in this block. And so we have a new reference for the next successor in this blockchain. And that's also the where the name of blockchain comes from. We build blocks and we chain them together. That's very simple and very basic. And now if we put these two properties and claims together, if you say you took all the properties and claims about distributed ledger technologies and put on top the data structure, we get the blockchain. That's all the magic in it. And there are not also, just to make it clear where the difference is, there's not just not the blockchain technologies, there are also other technologies which are also distributed ledger technologies, but not blockchains, like directed acyclic graphs or like the tempo, just to name some of them. As Axel mentioned, we will provide the slides later, so I don't want to go too deep in this slide. And because the next point is, now we know how the blockchain infrastructure is built. We can go to the next point and see how we can use smart contracts in this. Okay. There are some questions, maybe we can answer that later, if that's okay. So to come back to the smart contracts, we already mentioned that we can handle or automate processes or handle information in an automatic or even in an autonomous way with smart contracts. And so this topic, the smart contract topic, is also hyped like the blockchain technology itself. But if we have a closer look, smart contracts are not really smart, and they're usually not always contracts. They are more they are widely more simple. It's just like a vending machine. You have a defined set of inputs, data. You have a defined processing of this data, and you have a very clear and defined output set. So basically, there are just if-then conditions with defined input and a deterministic output. But they have their reason why they are also hyped with together with the blockchain technology. Also, they are already from 1994. Just imagine a vending machine, and imagine you are putting this vending machine somewhere, I don't know, in Russia or in Germany, with an expectation that if this vending machine stands there for a month and you sell all included cans, you will receive 1,000 euro. You put it there, you wait for it, you get information. In this way, the information are the currency, the coins you put in it, and you get an output. The customer gets its scans and you get the value. And you are expecting 1,000 euro because you put the vending machine with ingredients, with cans, in worth 1,000 euro. Because you have if you have a stable information basis like the euro or other currencies, your expectation won't be so wrong. You will get 1,000 euro at the end of the month. But imagine you put something like this vending machine in, I don't know, maybe Venezuela. You put it there, you get your information in this time in form of the Venezuelan bolivar. But the output is not the correct output because the information basis is not correct, not reliable. You would get just approximately something about 600 euros at the end of the month. That is the difference why smart contracts are also hyped with the blockchain technology. The information this autonomous tasks are held, they are reliable, they are trackable. If you have an information or a trigger in the blockchain, this information is verified by all participants. That the sender of this information was legitimated, that he had the rights to put this information into this network. It's not really the automation which is the new thing with smart contracts. It's more the reliable information basis, and that's the reason why smart contracts are hyped with the blockchain technology, and they also belong there. The next part is, which is always not really clear, is that they are not the blockchain and not the one blockchain. There are different blockchains, and there are also different classes of blockchain. The more widely known one is the permissionless blockchain, like the Bitcoin, where you have no handling structure. It is permissionless. Everyone can join it. Everyone can be part of it. And there you need strong mechanisms to verify who is able to deliver information to this blockchain, because you don't know who is part of the network. But on the other hand, for the industrial use, it's better to use permissioned blockchain, because you have here an closed circle of participants. You know who is in your network, and therefore you have also administrative functions, who is allowed to set information to the blockchain, who is allowed to retrieve information from the blockchain, and therefore, and because you know who is part of your network, you don't need very hard and complex algorithms to verify who is contributing information to the blockchain. And because there are different types of blockchains, there are also different types of nodes. Not just one, the full node, who is capable of holding the information and also generating new blocks. There are also administrative full nodes who have additional administrative rights, maybe about who's allowed to join the network, who's maybe allowed to leave the network, who's allowed to integrate more light nodes to the network to contribute information or to retrieve information. And there are also these light nodes, which the light nodes don't need to hold the whole information. They don't need to hold the whole blockchain, but they're part of the network. And so if a light node sends information or retrieves information from the blockchain network, here is usually allowed to do that. So you have an opportunity to have an administrative overview about who is able to retrieve information or not. And with this point, because we also talked about light client concept, or about the IoT device, which is capable of retrieving or sending information to the blockchain, this is the concept which is behind that. And if there is an instance who is able to send information to the blockchain in a new transaction, so there is the question, how is this new information handled in this blockchain network? Therefore, there are different type of consensus mechanisms. maybe you heard of some of them, maybe some of them are new to you, but the general function about this consensus mechanism is to generate a consensus about the new status of the network. So like in the scheme on the right, if a new information retrieves the network, so this information needs to be inserted into the network, so it must be spread in the network and distributed, it must be verified, and so the whole network must reach a new status. So that is, okay, this is our new information and we want to hold this information in our network. And so, like we said, a distributed ledger or the blockchain technology needs to synchronize the information about all on its nodes. The consensus mechanism is the algorithm behind that who is capable to do that. And how it's done, therefore, there are different mechanisms. Maybe the most popular one is the proof of work, which is also included in the Bitcoin. Here, you have you set a motivation for all participants or who wants to insert information to the network. In this case, it's your effort. So you have to put time and effort in your work just to put information, just to build a block and put this block into the blockchain. So it is very inefficient, and it's very expensive to put, or to just to try to put wrong information into the blockchain, because there's a puzzle, a cryptographic puzzle, which needs to be solved. Just a quick explanation. If one of the miner in a blockchain in a Bitcoin network or in a blockchain network which is capable of the proof of work consensus mechanism, they put transactions in a block, and then they have to put an additional random information in it. And the only purpose of this random information is to generate a hash value which has a defined pattern, like 4 zeros at the beginning. And therefore, the hash algorithms, they're not computable. They are because they are easy to verify, but very hard to guess. So you have to guess this random information again and again and again until you get a hash value which has the patterns. And that is the whole energy wasting and behind the Bitcoin, because the mining is just to guessing this random information to retrieve a defined pattern for your hash value. And so there's no real need of it. There's no real reason for it. Just it is just to fulfill the motivation that it should be very inefficient and very expensive to put an information into the blockchain, which can be easily verified as false information by other nodes. But also there's another way to get a consensus, the proof of stake. Here it is the motivation that if you have a lot of value, let's just say coins in a blockchain network, it shouldn't be your interest to corrupt this network. So I don't know, like if you held a lot of dollar, it would be not nice for you if the inflation in the dollar network in the USA would be very high. So for the mechanism is, if validating or a mining full node tries to contribute in a new block to the network, he puts some of his private coins at stake. It's like putting them in a safe. And if he is the chosen one who is allowed to put his new block or add his new block to the blockchain, he will retrieve his coins and also a fee. So he is granted some benefits of it. But if he is working malicious and the block he has contributed isn't right because, I don't know, the hash value is wrong or something like that, he loses his coins. So he has a high interest on working on the correct way and not corrupting the system. This is another way of generating consensus. And one not so really decentralized way of generating a consensus mechanism is the proof of authority, where some nodes have special privileges that they're allowed to authorize a new block and contribute them to the network. This is something like how you say it? It's working on reputation. If your reputation is high enough, then you can authorize new blocks. But if you work malicious, then your authorization, your reputation will decrease, and you would lose your authority to verify new blocks. So in this case, it's not really decentral, but it's sometimes used in industrial networks where you have some maybe big players who host the network, or don't want to give up their influence about the network. These are proof mechanisms or consensus mechanisms which are capable to handle permissionless blockchains. So blockchains where everyone is allowed to join and everyone to contribute information. But if you have a permissioned blockchain where you know your participants, and if you know how many participants are in your network and how many of them are full nodes which are capable of contributing your blocks, you can choose a way more efficient way, just like the round-robin algorithm. So they just take turns by providing new blocks. It's very easy, it's very efficient. You can put some security mechanism in it, like a contributing block node is able to contribute 2 blocks and then has to wait until other nodes contribute new blocks, so that he didn't block the adding process. And you don't have energy wasting here. You have way more input in these blockchains, but they are just working on permissioned blockchains because you need to know how many participants are there. And
Timo?
Yes.
Yeah, we just need to check with Andre. Do you have follow-up meetings? Because we have now 5 minutes. So I would just say, I mean, there's a couple more slides, but then we should come to.
Yes, I think that if possible, we may follow up, and there are some questions in chat, and so we may continue with these questions.
Yeah, okay. So I would just, Timo, I would just go to the last slide. I mean, you can just quickly scroll through so everybody sees what's coming, and then we will share the document. So just skip through the next slide if you can, to the last one.
There was just one more very interesting algorithm there, and then about integrating light nodes, benefits of it, and a little outlook about where the research is heading. And after that, then we would be finished.
Yeah, we summarized a little bit the key takeaways for blockchain and applications and supply chain and etc. And as we said before, we will share this slide deck. Shall we send it to you, Andre, and or to Alina, and then you can share it in the group, and then we're happy to follow up on this. And if there are immediate questions right now, apart from the ones in the chat, we already answered a few of them. So if there's anything now that you want to ask, we're still here.
Yes, thank you, Axel. And there are some questions about the procedures. So who usually is integrator of Internet of Things in supply chain management in your practice? So as I know, in Russian market, usually telecom companies are integrators of such solutions. What's how is in Germany?
Well, basically, I mean, there's a lot of companies from the financial sector. We have banks providing services or solutions more and more. We showed that Commerzbank is very interested in finding new products and solutions. For example, in the pay-per-use area, we have logistics companies and some of the big OEMs in the automotive industry working with us. Those things. What Timothy said at the end, I mean, the differentiation between permissioned and permissionless networks. Naturally, we see a high potential for permission frameworks based on permission infrastructures, because there we can create private blockchain networks compared to the permissionless that are used for crypto, like Bitcoin, etc. So we see a lot of potential there to set up private networks in a big or small consortium. The bigger it is, the more the potential is there through scalability, naturally, but also more challenges towards concerning interoperability. So we're also working on this. But in general, it's more and more interest. And as we said before, I think a lot of business will be based maybe in the back end, not in the front or directly visible, but in the background, there will be lots of operations more and more done on based on blockchain. You can also see that in many industries, and so there are many stakeholders already pushing that in Europe and across the world, I guess.
Thank you. And also one more question. What are the barriers to implement Internet of Things in supply chain from your point of view? For instance, maybe it is security reasons and cost and benefit analysis and something like that. The most often barriers for decision makers.
Yeah, I mean, there's some sometimes it's a psychological barrier also. Concerns about new technology, about data security, about cyber security, right? I mean, this is how legal are transactions, for example, that we are currently working together with lawyers also on this, and some ministries that are interested in how can we make actually transactions and contracts that were set up between machines and not humans or companies. So not machines were actually are sort of complying to a contract or setting up contract. So how legal is that? What is if something happens? Who is responsible? So these are some areas where there is uncertainty and lack of knowledge, and so these are barriers definitely, and also naturally the cost. The thing is that what we try to do is see if there's a business case. So business calculation, cost and benefit calculation is important. How much do we need to invest in order to set up a IoT blockchain infrastructure, for example? Can we use existing infrastructure? I think that is very important. And if you look at all the devices today, like smartphones being used to track information, read informations, sensor technology is becoming, prices are going down, sensor capability goes up and prices are going down. So this will be more available, and that makes business cases more probable. But we have to look at that definitely. And this is a requirement also eventually.
Thanks a lot. Dear colleagues, participants, maybe one more short question.
I see there's a question which I would like to answer. A question about blockchain ready sensors. In our case, they are not Arduino based. We choose for our little prototypes Raspberry Pi. But like Eugen said, basically you can use almost any kind of micro controllers. We also published a paper about, like Axel said, about multi-light nodes. The light node concept, it's the key to include sensors or other technologies, or like any kind of CPS to the blockchain networks. The minimum is to handle private public key on a microcontroller. But if you have any integrated sensors, like they are produced by SICK or other companies, if they have additional security possibilities, like verifying the hardware, like the EMI on smartphones or something like that, there are also good additional functionalities. But we are also capable with this blockchain gateway to retrofit older systems, like if there's any kind of production system which has the possibility to be controlled by a microcontroller. I don't know, like something like COMP1 or RS323 bus or something like that. If we have a microcontroller and some functionalities on it which can transfer this to the communication ways of the underlying blockchain implementation, you are able to include these sensors or other components.
Thank you.
Thanks a lot. Thank you.
Okay, what we can do, Andre, we can share these documents. I was just thinking, since we have this white paper, we are happy to attach the white paper on the multi-light node concept. So if there's any interest in that, just go through. It's written, it's technical, but it's still readable also on so technical people. Okay.
Okay, so if possible, you may send this information to Alina Ruchilova, and she will
I will do.
allocate this. Okay, dear colleagues, many thanks. Dear participants, dear speakers, it was my pleasure to meet you here in our webinar. So thank you for your cooperation. Danke schön. So hope to see you again in reality. Yeah, thank you.
Welcome, welcome. Andre, say hello to Konstantin.
Yeah.
Have a nice end of the year and Christmas, as far as you celebrate.
Yes, thank you.
Nice to see you.
Yeah, bye-bye.
Yeah,
Thank you all. Bye.